Hello, everyone. This is another Paleo-Zoo-Keeper Rant. My name is Austin. I have a rant on some things I've heard lately, and basically a scenario has popped up in my mind. I'm pretty sure some of you who follow this sort of topic would know that there have been a lot of groups that talk about resurrecting the thylacines. Different groups claiming to be able to do that in a short period of time, especially with the genetic science advancing pretty nicely. I have also been hearing of both eyewitnesses and even scientists suggesting that the thylacine, or Tasmanian tiger, is still alive in Tasmania, Australia, and New Guinea. And there have been many cases of species that have gone extinct and only to be suddenly rediscovered after a short period of time. These are generally called Lazarus species. Black-footed ferrets are an example of that. And then I remember a comment from a documentary about cloning the thylacine, and it was that why would you clone a thylacine when there's still some around? And it got me thinking on how would it go if we had both resurrected thylacines in a lab and found a living population of them in the outback at the same time. This hypothetical scenario is definitely a fascinating concept to me, and would make one wonder which one will be more valuable. I think that this would depend on certain circumstances. If there were thylacines found in the wild, depending on the population numbers and the genetic difference between the thylacines in the of the three different land masses, the population could be classified as critically endangered or endangered. Critically endangered is the low end, basically right before extinct in the wild and then extinct. If the populations of each land masses, Tasmania, Australia, and Papua New Guinea, are distinct from one another, that would definitely affect their conservation concern status. For example, both species of African elephants were thought to be not that distinct from each other, and then together they were classified as just vulnerable, which is just below threatened and then to least concern. And after they were genetically shown that they were genetically distinct, this changed the category that the African bush elephants, the classic savanna elephants that we know, is now considered endangered, and the African forest elephant is now considered critically endangered. If the only thylacines that are around were born from a laboratory, how they are resurrected would determine their conservation value. If they were simply pure thylacine clones, well, pure would be relative, since that it's most likely that while they would have the nuclear DNA of a thylacine, they might not have the mitochondrial DNA that they get from eggs, unless they found a way to create thylacine oocytes or eggs, just like how we were able to make mice that can make elephant eggs or oocytes. Then then they could definitely be seen as thylacines more readily and would be classified as functionally extinct or extinct in the wild, basically both referring to that it cannot survive without human assistance. But if the thylacines were resurrected via heavily modifying the chromosome, the genome of a living relative like a numbat or dunrant, I hope I said that right, with thylacine DNA, then they would technically not be thylacines and would most likely be seen as, well, hybrid freaks with little to no conservation value. And it would get political about whether to call them thylacines or not. But since there are no other thylacines around, and that may be the closest thing we will have to thylacines, and they look and act like thylacines, most would start to accept them as thylacines resurrected. Kind of like how we accept bison as bison, although a good amount of them have cattle genetics in them. Now, if the cryptid thylacines, or basically from cryptozoology, were discovered in the outback long before any lab-grown thylacines were born, I think it would be imperative that the living ones should be observed and studied, especially study their genetics. If the living thylacines have a low or even lousy genetic diversity compared to old museum specimens, then it would be a good idea to probably either clone those museum specimens or genetically modify the living thylacine genome with genetic material from the museum specimens. This would result in thylacines to have a greater genetic diversity and could be able to be as a genetic rescue for the surviving species. These ideas are reminiscent to what's currently going on with the cloning of two Savolsky's horses recently, and a proposal on modifying black-footed ferret DNA with genes from museum specimens to improve the gene pool. If the cryptid thylacines were discovered around the time that the first lab-grown thylacines were born, how the thylacines were resurrected would determine their conservation value, as mentioned earlier. If they were simply clones, then they would have significant conservation value. If they don't have the thylacine mitochondrial DNA, then only the males would be useful for breeding, since most of the time, if not all the time, males cannot be able to pass their mitochondrial DNA to their offspring. That's only the females do that. But if thylacine oocytes or eggs were able to be recreated and they have a thylacine mitochondria, then the clones of both genders from these eggs would be useful for breeding. If a wild individual or individuals could be brought into captivity to these clones, they might be able to both reintroduce true thylacine behaviors and mannerisms to the clones, much like how Kirk the Savolsky's horse clone given was given a regular Savolsky horse friend, so he can learn how to become a real Savolsky's horse, and behaviorally and manner speaking, and and this will also be able to help expand our understanding of the species. But if the resurrected thylacines are basically, one would say, a thylacinified numbat or dorant, then I think that they will have no conservation value if pure thylacines, true thylacines, were rediscovered back in the wild. This is most likely because, due to the possible genetic differences between the lab thylacines and the true thylacines, these two animals could not be able to interbreed with each other. I can imagine that the lab thylacines from this scenario will probably have 90 to 95% of thylacine DNA, and the 10 to 5% difference would definitely be significant enough to make them different from one another. For example, American bison only share like 90% of DNA with cattle, with a 10% difference, and that still makes them pretty different from one another. And in this case, I would also say it will also be similar to how the American and Eurasian beavers look similar to each other, but they can't be able to produce viable offspring. I mean, the closest thing that a report has had was that one result from this bond only had a stillborn litter. But other than that, if true thylacines were found in the wild and the thylacinified animals were born in a lab, unfortunately, I think there will be calls for those lab-born thylacines to be put down. In another scenario, if the lab-grown thylacines were born, bred, and reintroduced into the wild, only for true thylacines to be discovered in the wild afterwards, how the lab thylacines were resurrected would definitely determine the scenario. Best case is that if the thylacines from the lab were simply clones, then the lab thylacines could be the Judas goat, if you will, of the living thylacines, and their introduction could provide the proper genetic diversity for the living populations might need. Though whether the resurrected thylacines have the mitochondria of actual thylacines could affect things. Judas goat, I mean, like as if that the clone thylacines could be able to show that, hey, there are living thylacines out here, basically. But if the lab-grown thylacines were simply like thylacinified numbats, for example, they would be considered an invasive species. Since they could not be able to interbreed with each other with the true thylacine populations, and they will compete with the living thylacines for prey and territory. While I definitely know that these kinds of scenarios are random, they're both intriguing and they provide a thought experiment so that we can be able to visualize and properly think out the pros and cons if the scenarios are to be. I definitely think that if we have found thylacines in the wild, cloning technology or basic genetic technologies that we developed to try to resurrect them would definitely be useful and helping the species. I hope you guys liked my rant and made you think some things. If you want to see more of my rants or my usual video content, hit the subscribe button down below and you'll be staying tuned. I hope you guys have a great day. Adios.